Join me as I dive into the incredible journey of the Parker Solar Probe and see if it can survive its second blazing flyby of the Sun. The Parker Solar Probe is a groundbreaking mission designed to study the Sun, and it's just made its second successful flyby, bringing us closer to understanding our star's dynamics. The Parker Solar Probe faces extreme challenges as it ventures closer to the Sun, enduring scorching heat and intense radiation that would be catastrophic for any ordinary spacecraft. Its mission is critical for understanding solar dynamics, as it delves into the Sun's corona, the outer atmosphere where the temperature is incredibly high. This region is crucial for understanding the Sun's behavior, and the Parker Solar Probe is specifically designed to gather data from this extreme environment. The probe's heat shield is its most critical component, protecting it from the intense radiation that would otherwise destroy it. By studying the Sun's corona, scientists hope to gain insights into the solar wind, coronal mass ejections, and other phenomena that affect the solar system. The Parker Solar Probe's second flyby was a significant milestone, as it collected a vast amount of data that will help scientists better understand the Sun's behavior. This data includes measurements of the solar wind, magnetic fields, and high-energy particles, which will be crucial for understanding the Sun's dynamics. The second flyby was similar to the first, but with some notable differences, including a closer approach to the Sun's corona. Scientists are eager to compare the data from both flybys, looking for patterns and changes that could reveal new insights into the Sun's behavior. The probe's instruments are designed to capture unprecedented solar data, providing a unique glimpse into the Sun's inner workings. The second flyby was a complex operation, requiring precise navigation and control to ensure the probe's safety. The Parker Solar Probe's team had to carefully plan the flyby, taking into account the Sun's intense radiation and the probe's heat shield. The probe's speed and trajectory were carefully calculated to ensure it could gather the maximum amount of data while minimizing the risk of damage. As the probe approached the Sun, its instruments began to capture a wealth of data, including stunning images of the Sun's corona. The data collected during the second flyby will be crucial for understanding the Sun's behavior and its impact on the solar system. The moment of the probe's closest approach to the Sun was a thrilling moment, as scientists waited with bated breath to see if the probe would survive the intense heat and radiation. The probe's heat shield performed flawlessly, protecting it from the extreme conditions. The instruments on board the probe captured unprecedented data, including measurements of the solar wind, magnetic fields, and high-energy particles. The data will be carefully analyzed, providing new insights into the Sun's behavior and its impact on the solar system. The probe's closest approach was a mere 15 million miles from the Sun's surface, an incredibly close distance that allowed it to gather data that would be impossible to collect from a safer distance. The instruments on the Parker Solar Probe are designed to capture a wide range of data, from the solar wind to high-energy particles. The probe's magnetometer, for example, measures the Sun's magnetic field, providing crucial insights into the Sun's behavior. The probe's solar wind analyzer, on the other hand, measures the solar wind's speed, temperature, and composition, helping scientists understand the Sun's impact on the solar system. The data collected by these instruments will be crucial for understanding the Sun's dynamics and its impact on the solar system. The probe's closest approach to the Sun was a historic moment, marking a major milestone in the mission. The key findings from the second flyby are a significant step forward in our understanding of the Sun's behavior. The Parker Solar Probe has proven itself to be a groundbreaking mission, providing unprecedented insights into the Sun's dynamics. The data collected during the second flyby will be carefully analyzed, providing new insights into the Sun's behavior and its impact on the solar system. The Parker Solar Probe's mission is a testament to human ingenuity and our desire to explore the universe. What do you find most fascinating about the Sun, and what do you think we can learn from this mission? Check out my other videos on space exploration to learn more about the latest discoveries and missions.